right, so I'm on page 5. This is not page 5, but I'm on page 5 of your packet. So before we can talk about arc length and sector area of circles, we first just need to talk about what sectors of circles actually are and why they're important. So a portion of a circle is bounded or surrounded by 2 radii, which remember radii is the plural for radius, and an arc, and this is known as a sector. So basically, when 2 radii meet and the arc that's between them, that's your sector. It's a piece of the pie. That's what a sector is. It's a piece of the pie. That's how you want to put it. So it's a piece of the pie. That's what a sector is. Now, sectors are really important in design and engineering and mathematics, as well as pizza. Have you ever thought over how big your pizza slice is? That's another way you can describe it. A slice of pizza, that's a sector. Okay? Now, basically what we're going to be learning about today is how to find the area and the arc length of these sectors. So let's look at exercise 1. Circle O is shown below with a radius of 12 inches, and the sector has been defined by 2 radii, OB and OA. And it has a central angle of 60 degrees. So if you look over here at this picture, this shaded area right here is your sector. It has that angle of 60 degrees in it. It's formed by those 2 radii, and each radii is 12. And it also has the arc length, or the arc that's between those sectors. Now, think way back to Unit 6 when we talked about circles. This in geometry is known as a minor sector, created by these 2 radii. Why do you think it includes the word minor? So it's what? It's less than 180 degrees. So this is the kind of the same thing as a minor arc. Remember when we talked about those? Minor arcs are less than 180 degrees. Same thing with minor sectors. The angle that forms them will be less than 180 degrees. So it's because the angle of the sector is less than 180 degrees. Now, before we determine the area of the sector or the arc length of the sector, we first want to find the circumference and the area of the whole circles. So this is like 7th grade math here. What is the formula for circumference of a circle in terms of radius? So what's the formula for the circumference of a circle? 2 pi r. So 2 pi r is the circumference of the circle. What about area of the circle? Someone else. What's the formula for area of a circle? I'll give you a hint. It's part of the cylinder formula for volume of a cylinder. It's just missing one piece. So area of a circle, what's the formula? You guys should know this. Come on. It's going to have pi in it. It's going to have radius in it. Those are the only 2 components. Close. Not quite. It's what? Pi r squared. Good. You got to know those 2 formulas, guys. Okay, so now let's actually find the circumference and area of the circle. So using this formula, we know my radius is equal to 12. So for both of these, r is going to be equal to 12. So I'm going to plug this in. So c is equal to 2 pi times 12. What's 2 times 12? 24. So c is equal to 24 pi inches. All right, that's the exact. Now put that in your calculator and tell me what the approximate would be. Round to the nearest hundredth. So 2 decimal places. It's 25 point what? 0.3. Okay. So 75.39 inches if we round. So this is my circumference. Area, we're going to do the same thing. So area is equal to pi times 12 squared. What's 12 squared? 144. So the area is equal to 144 pi inches squared, because it's area. So if you put that in your calculator, what is it approximately? Someone who's not spoken yet, what is it approximately? Put in your calculator if you don't know, which I doubt you would. That's kind of an obscure thing. $452.39, you said? Okay. Inches squared. So we found the circumference and area of the whole circle. So that's what the circumference of this whole circle is 24 pi. The area of this whole circle is 144 pi. So it then wants to know what proportion or fraction of the circle's area and circumference are contained in the shaded sector. So think about this logically. How many degrees is this sector? 60. All right, if they told us that, 60 degrees. What do you think, do you think I'm going to create a fraction to know how much of that circle 60 degrees of that circle is? You're going to divide it by 360 because how many degrees are total in a circle? 360. So in other words, we want to know how big the piece of the pizza is. Okay? We want to know how much of the pizza we were given. So we're going to take 60 degrees. We're going to divide it by 360 degrees. So what would that fraction be? So remember how I taught you how to simplify fractions yesterday in your calculator? Put in your calculator, hit math, enter. What? 1/6. Good. So in other words, if we divided this pizza evenly, we would get 1/6 of the pizza. So it's a 1/6 piece of the pie. That's how much of the area and the circumference that we have, 1/6 of it. So given that little tidbit of information, how do you think I'm going to find the sector area and the arc length? So think about it. We got the whole, and we got how much of the whole we want. So what do you think I'm going to do? Okay. Let's think about this one, guys. Let's go back to elementary school with some fractions here. All right. This is a course, right? Okay. What if I told you that the area of this circle is 8? What's the area of 1? 2. How do you know? 2/4 is 8. But if I said this was, the area of this was 12, 3. How do you know? Well, divide by 4 is 3. Or you could multiply 12 by, how much of this pie is this? It's a fourth of it. Is it 12 times 1/4 equals 3? Yep. So what do you think I'm going to do here? if we got the whole, which is the circumference in the area, and we want a piece of that whole, we know how big that piece is, what do you want to do? Gonna do what? Times 1/6. Good. So we're going to take the circumference, multiply 1/6 to it. We're going to take the area, multiply 1/6 to it. Or divide it by 6, however you want to put it, but you're going to multiply that fraction to it. So, that's exactly what we're going to do. So I'm going to use the exact just so we get as close as possible. So for the arc length, I'm going to call that, I'm just going to say arc length. So for the arc length, we're going to take the circumference and times it to 1/6. So we're going to do circumference times 1/6. So that'll be equal to 24 pi over 1 times 1/6. So what's 24 pi times 1? 24 pi. What's 1 times 6? 6. If I simplify this fraction, what would it be? So what's 24 pi over 6 simplified down to? 4 pi. So the arc length is 4 pi inches. What is it approximately if you round it to the nearest hundredth? Let's put in your calculator, round to the nearest hundredth. So what is it approximately? It's what? 12.57 inches. So that is our arc length. So we got the exact and the approximates. So sector area, we're going to do the exact same thing. We're going to do the area of the circle times 1/6. So that would be 144 pi over 1 times 1/6. So what's 144 pi times 1? 144 pi. And then 1 times 6 is 6. What's 144 pi divided by 6? So what's 144 divided by 6 essentially? 24. So this is equal to 24 pi inches squared, which is approximately what? So what is that approximately? So what is that approximately? So 24 pi, if you put that in your calculator, what is that approximately? $75 point what? 74 point? 75.4. 75.4. Yeah. All right. So that's what our sector area is. We got the exact and we got the approximates. So guys, that's essentially how you calculate arc length and sector area. You calculate the whole area and circumference. You figure out how much of the circle the sector is by taking whatever the angle is and dividing it by the whole that a circle can have. So in this case, you'd be dividing either by 360 if it's degrees and 2 pi if it's radians. And you're going to multiply that fraction to the circumference in the area. And you got it. So let's look at another example here. So a patio is in the shape of a circular sector which has a radius of 20 feet and the central angle of 110 shown. So we're going to find the area of the sector to the nearest square foot. So before I even calculate the sector area, what do I need to calculate first? The what? We don't need the circumference. We just need the area. It's only asking for the area of the sector, not the arc length. So we just need to calculate the area. All right. So I'm calculating the area of the whole circle. So remember, that's pi r squared. So how would I set that up? Using the information that they gave me. So area is equal to what? Pi times 20 what? Squared. What's 20 squared? 400. So the area of the whole circle is equal to 400 pi feet. And we're going to leave it like that because we want our answer to be as exact as possible. All right. So again, this is the area of the whole circle. Now, I want to know how big is the piece of the pie. How do I find it? We are going to use 110. So I want to know how big of the circle, or how much of the circle, what fraction of the circle is this piece? I do 110 over 360. So to find how big this piece is, I'm going to do 110 degrees divided by 360 degrees. That's going to tell me how much of the circle this is. So I want to know how much of the circle. So what's 110 divided by 360 converted to a fraction? It's what?
1136.
1136. That's how much of the circle we got. So to calculate my final answer, I'm going to take these two pieces and do what? So to get my sector area, I'm going to take those two pieces, multiply them together. So my sector area is going to be equal to 400 pi times 11 over 36. I'm going to put the 400 pi over 1. What's 400 times 11? 4,004. Okay, so 4,400. All over 36, and don't forget the pi up top. Now, what's 4,400 divided by 36? If it's a fraction, just hit math enter to simplify it.
Well, 1,000 over 9? I gave you 9. Wait, wouldn't that be?
Did you hit math enter?
Yeah.
So 4,400 divided by 36. No, that's right.
What is that?
So, yep. So that's equal to 1,100 pi over 9 feet squared. Now, that's the exact. What's the approximate? So put 1,100 pi in first, hit enter, and then hit divide by 9. Because if you don't, it's going to read it funky. It's what? 383.97 feet squared. So that's my sector area. That's how big this patio is going to be. About 383 feet. Yeah, you guys are doing good. So does everyone kind of understand how that works? Like how this is working? Like what's the general process? Okay. I want you guys to try this next one on your own. So don't be thrown off. It's still a sector. They just didn't draw the whole circle. Okay, so
Semicircle.
that's not even a semicircle.
They just section of a circle.
It's just a section of a circle. They just didn't draw the whole circle.
So what kind of
So you're still finding the sector area. Just imagine that there's a whole circle here. That's a terrible circle, but it's like just imagine there's a whole circle here. You're finding whatever they want for that sector of the whole circle. So basically exactly what we've been doing. Give it a shot. But read carefully to see what they want, because I'll tell you whether you need to find the arc length or the sector here. Well, that'll tell you, dictate whether you need to find the circumference or the area of the circle. So I'll give you a hint. Find the circumference or area to the whole circle, depending on what it's asking for. So I'll give you another hint. It's talking about fencing. So fencing. Fencing typically refers to what? Circumference. It's talking about how much fencing they need. So in other words, they're talking about lining that sector. So you need to find circumference first.
She's looking at us. It's not just impressed. I just go straight to hold this morning. And then sure. He's not that back, so. Just since I did the time.
All right, guys, thumbs up if you're ready. All right, I see a lot of heads down, so I'm just gonna assume that's a yes. Okay. So, a garden has a shape of a circular sector such that the straight sides measure 50 feet in length and the central angle is 132 degrees. The garden needs to be surrounded by fencing. How many feet of it are needed? So, first things first. We're talking about fencing, and we know fencing typically is just the outside. You're not going to fence, all of the inside of a space. Okay, so that means we're using what? Circumference. So I need to find the circumference of the whole circle first. What's going to be my radius? 50. 50 is your radius. All right, you just got to imagine that like they actually drew the whole circle. In this case, they just gave you the sector. So don't let that throw you. So we're going to do 2 pi times 50. I don't know why I wrote 500. So the circumference of the circle is 100 pi feet. I'm just going to leave it as 100 pi for right now. I just found the circumference. That's it.
Yeah.
It's just 2 times 50, and then you just leave the pi on. If you already put the pi in, that's probably why. Like if you gave the approximate answer, which is fine. You can do that.
You can do that?
Yeah.
Okay. It's about 200.
So,
Yeah.
yeah.
Okay.
Yeah. So you just multiply the pi in already. That's fine. That's fine. Okay. Now, we need to know how big of the piece of the pie is. So what do I do to find how big that pie is? So how big of a piece? We do 132 divided by 360. So as a fraction, that would be what? It's what? 11 over 30 or 40? 30. So 11 over 30. That's how big of the pie we got. So now to find the arc length, we're going to take these two parts and multiply them together. So I have 100 pi times 11 over 30. So if I multiply dead across, I would get 1100 pi over 30, which I think that simplifies down to 110 pi over 3. Correct me if I'm wrong. So this would be equal to 110 pi over 3 feet. So approximately that's what? So what is that approximately? $115 point what? 90? 19. I'm sorry, I'm deaf. Feet. So that is approximately the length of this arc up here. However, that's not quite the answer to this question. That's just a part of it. But what's it asking for? How much fencing do you need to enclose the entire sector? So there's one last thing that we got to do. So what do we have to do? We got to add the 2 sets of 50 to it, or add 100. So we got to make sure that we add these 2 pieces as well. So I'm going to add 50 plus 50, so that's 100. So this should be about, 215.19 feet of fencing. So when it comes to questions like these, guys, just be careful, okay? So just be careful, because sometimes they'll be like, oh, find the area of the sector. Oh, that's easy. But then it'll be like, how much fencing do I need total? And they'll have 2 pieces that you end up having to add on at the end. So just make sure you read the question carefully. All right. Let's do one more and then, 2 more. So let's do these last 2 and then we're going to move on to the journal entry, which honestly the journal entry is kind of more the same. I just want to do 1 or 2 problems on it. Okay, and then the rest I'll just have you guys copy. So, okay, so a sector of a circle whose radius is 5 centimeters has an area of 20 square centimeters. Is the central angle of the sector acute or obtuse? So this one's a little bit different. It's talking about the angle. So we got some circle and we got some sector, and I did not draw it to scale because I don't know whether it's big or small, but we got some sector. They say that the radius is 5 centimeters. So both these lines here are 5 centimeters. They then said that the area of this sector, so this area is 20 centimeters squared. And they want to know what this angle is and whether it's acute or obtuse. So let's think about this logically. Think about what we use the angle for. So think about what we use the angle for in previous problems. What did we typically use the angle for in previous problems? We use it to find the sector area, but specifically what? Right, how big of the pie it is. Okay? So in other words, we can kind of reverse engineer that, right? If we find out we already know how much the pie it is. We just need to find out what the whole is and then do what? So is it not true that this is a piece of the pie? Yeah, that's a piece of the pie. Could we figure out the whole if we calculate it?
Yeah.
Couldn't I get a fraction of that? And then okay. So let's start by finding the whole first. You'll see what I mean in just a second. Okay. So area of a circle, pi r squared. All right. So the area is equal to pi times what squared? What's the radius? 5 squared. So the area is equal to 25 pi centimeters squared. So this entire circle is 25 pi centimeters squared. Now, I want to know how much 20 centimeters is of that 25 pi centimeters. So what fraction 20 centimeters of 25 pi centimeters is? How do I set that up?
Yeah.
So I want to know what actual fraction or how much, like fraction-wise, is this piece of the pie. So I don't have the angle to do that, but I have enough information to do that. How do you think I would do that? Divide what? You got it, just go further. Divide what?
Divide.
1 by 360.
No.
Well, not yet. It's typically the angle by 360, so in other words, the piece by the whole. So use that same logic with what you got. There you go. Good.
20 over 25? Yeah.
25 pi.
25.
So,
I'm slowly. Okay.
so we want to know how big is the piece. And to do that, we're going to do 20 divided by 25 pi. In other words, it's the piece over the whole. Whether that piece is in degrees or radians or, centimeters squared. As long as it's the piece and you have both pieces and the whole, you can divide them. So if I simplify that down, this would be 4 over 5 pi. And I'm just going to leave it like that for right now. Now, that's how much of the fraction of the circle that we got. How do you think I can then use that to find degrees? So this is the size of the fraction. So let's say the pi wasn't here for a second, because that might make it a little easier to understand. 4/5 of the circle. How would I know what 4/5 of the circle degree y is?
Is this really?
Divide by 360, opposite.
Times it by-
Multiply 360. So in other words, since we got how big of the piece it is, or how much of the circle this is, we just have to figure out how much of 360 that is.
So it would be. How does that say?
So to find the angle, we're going to take 4 over 5 pi and times it by 360. So first off, when you put this in your calculator, make sure you put 5 pi in parentheses. So do 4 divided by 5 pi first, and then times it by 360, and tell me what you get approximately. It's what? 7.07. I trust you, I'm just double checking. Make
Yeah.
Okay. Did you put the 5 pi in parentheses? So 4 divided by 5 pi, and then you multiply the 360 to it after you hit enter. Yeah, don't put them together because otherwise you're gonna put way more. It's what?
91 point, would it be 7?
Yep, 91.7 degrees. So, is that going to be an obtuse or acute sector?
That would be.
Obtuse. Obtuse, because it's greater than 90 degrees. It's an obtuse sector. Well, actually, no, it is. It is. All right, so using that same logic, try number 5. So using that same logic that we just used, try number 5. So make sure you're finding the right thing. All right, guys, so let's talk about this. So, a horse is attached to an 8-foot long rope that can rotate through a distance of 28 feet. What angle can the horse walk about? All right, now, are we talking about sector area or arc length here? So is the 28 the sector area or is it the arc length? It's the arc length. Now, if you have issues telling that, it's really, really easy. Just look at the units, okay? Sector area is always going to be in some units squared. All right, that's always how area is written, some units squared, so like centimeter squared, feet squared, whatever. Arc length is just written in straight up units, so feet, centimeters, inches, whatever. Okay, so if you're confused on which one to use, look at the unit. They'll tell you. So this is the arc length. So that means we need to start by finding the what? Circumference. So our circumference is 2 pi r. What's my radius? 8. So I have 2 pi times 8. So this is 16 pi feet. And I'm going to leave it like that for right now. Okay? If you already went ahead and multiply the pi to it, it's fine. Because it's multiplication, so you can move things around because it's commutative, and it still do the same thing.
For me, I was just thinking it's right.
Yeah. You're literally just doing 2 times 8. So like up here when we did 5 squared, 25, or like previously up here, 2 times 50, 100. Yeah, I'm not doing any kind of special science. It's just, hey, if it clicks, it clicks. Now, I need to figure out how big this piece is, or what fraction of the whole circle this is. How do I find that? I do what? So what did we do in the previous problem?
Yeah, no. 16, well, what did you 28 over 16?
Yep.
Okay, sorry. It took me a long time to get that.
You do the piece divided by the whole. Now, you could just flat out put that in your calculator if you want. I'm just going to simplify it down. So this would be about, if you simplify it down, honestly, you don't even have to simplify it down. Just leave it like that. That's how big the piece is. It doesn't matter like how big of it is, just as long as you get that piece over whole, you don't have to simplify it. Now, we then want to know the angle. So angle, how do I do that? So we got how big of the whole circle this sector is. So how do I find out how much of it is degree-wise of the circle? What do we do up here? We times it by 360. That's exactly what we're going to do here. So if I put that in my calculator, make sure you put parentheses around the 16 pi. Do 28 divided by 16 pi, hit enter, and then times it by 360, and tell me what you get approximately.
Uh, 200.54.
200.54. So it'd be about, so it's approximately 200.54 degrees, which if we round to the nearest degree, it'll be about 201 degrees. So this angle is about 201 degrees. Okay, here's my question for you guys. The foldable is pretty much just more of this. Like there's not really anything different on there. So here's my question. I have a key to that foldable already. Do you just want me to post it and you guys copy like a normal journal entry? And so you guys can work on classwork for the rest of class? Okay, that's fine. Okay, so I'll do that. There is a new Delta Math. So guys, there's a new Delta Math. It's 8.2. It covers this stuff. You know what? It works. It works. It works.
You should
That what?
you should call me and let me know if you used an unauthorized test.
It's a burner notebook. Well, we can't do anything unless we got the evidence. That's a new one. I never heard of someone having a burner journal. That's a new one.
But you know what? And
Uh-huh.
right, so I didn't. It's a,
Because it looks exactly the same.
yes, it is.
Looks exactly the same, yeah.
I didn't see tabs. I didn't see like tabs sticking out.
But not all of them do tabs anyway. No, you're good. I'm just plugging my computer in case it's about to die a horrible death.
We're downstairs.
I mean, it's. I don't.
I'm not sure what that.
Hold on. Hold on.